Hello everyone. Today I'm going to talk about how to design a connection for beam that connects to column in idea StatiCa. So first we open the connection program here. Now we need to select which type of connection we want to design. So this is what the connection that I want to design, and I will choose this type. And for the type of connection itself, I will not select any of this because I want it to be blank so that I can show you how to add the connection type, any type that you want later. Now next we need to look at the parameters. First, the steel rate, I will use A36, and I will keep the option here to be the default here. And now we can start our connection design. So first we need to add the cross section for our member beam and column. So for the column, I will use the Japanese standard. So I click on H Japan here, and the size is H300. So this one will show here. And for the beam, I will use the Japanese standard also, but the section is 500. It is the I section. So this is the member that I want to design the connection for. But I want to add another beam here. So I'm going to copy this, but I will change the direction here to 90 degree. So now this beam turn 90 degree from the original location. Next, we adjust the load combination here. So this is the critical load combination. So you need to run the analysis first. So first I will add the shear. So you can see the load on the arrow here. I think this should be positive, as you can see in the direction of the arrow here. Okay, now it's already done for the load combination. So next you can add the connection to the model here. First you can select the operation button here and choose any connection you want, but you can also add the connection by right click on the beam member and select connect to, and choose the column that it's connect to. So now you can choose any connection that you want. In this case, I will choose this type of the connection, and the bolt is 20 mm A325M. So it will generate the connection automatically for you. Next, I will add the connection for the beam here. I will do the same for the previous beam, and I want to use the end plate here because it's good for the beam to the two column connection. The other connection is it's a lot difficult to make in real connection. You can also choose this type of end plate. It can resist a lot more moment, but I will try this first. If it's not passed, I will adjust it later. Now I want to change something here. First I will turn on the transparency. As you can see here, the beam stay inside the column flange here, so it's not easy to install in the construction site, because when you install, the beam will clash with the column here. It's difficult to put the beam inside the column flange, so I will offset the beam here to outside of the column. Now I will turn on the transparent again, so I will adjust the gap here. First isolate the plate here and change the gap, and I select this. I change this also. So now the beam is outside the column flange. I need to adjust this also. So this is how I want it to be. Now I will change the plate here. First I will change the thickness. Let's say 12 millimeter, and next I will change the ball here. I want only 3 row, so we change this to, you can always try the number here to see how the ball is placed on the connection here. You can also start with 0 and then 20 or anything that you think is fit for the plate here, but this is how I want it to be placed on the plate here. But I want to change the start point a little bit to stay at the same location as this ball. So I will adjust the overlap here. I think it should be okay, it's not right, it's still a little bit longer than the middle ball here. No, I think it's okay. So next I will change the wheel size here. Now I will adjust the plate, the middle plate here. I want it to be only 10 millimeter, and I want to use only 4 bolts. So I will change this. Thing. Okay, I think it's good now, but I need to offset the plate a little bit more. And next is the wheel size. Okay, so this is looking good now, but I also need to change the bottom plate here, but I don't want to change this again and again. I want to use the same type of plate and the same number of the bolt at the top flange here, so I'm going to delete this and select this, and I click on the copy here, and I will change the member part to bottom flange. The plate is not generated correctly, so I need to change the location here from rear to front. So now it's look okay. Okay, next I'm going to adjust the end plate here. I will change the thickness first. Let's say 12 millimeter, and I think I want to use the two profile symmetrical, and I will change this to something like this, and I will keep the left layout to be default to the default value here, and I only change the wheel size. Now the connection is almost done. All I need to do is add the stiffener at this location and this location. So I need to click on the operation here and click on the stiffener. The thickness is only 6 millimeter, and I only want the stiffeners to be wheel at one side only, and the thickness is 6. I think it's okay now, but the stiffener is put at both side of the column. I don't want this side to have the stiffener, so I remove this by choose the location here. First I will try the front first. Okay, it's fine now. So our model is done now. Next you can run the analysis, but first you need to make sure that this option is correct for your project. If you use ASD, you need to select the ASD load combination type, but in this case I use LOFD. So now I'm going to run the analysis by clicking on the calculate button here. The analysis is now start. Sometimes it takes a while to design the connection, so make sure that you keep the connection simple and economical as much as possible, so that you don't have to be complicate the connection both in design and the real life work. Now the connection here is okay. You can check on the summary of the design at the top left corner here. The analysis is 100% complete, so it's okay. The plates is okay, and it's not too thick or too thin, so you can use the thickness and the bolt is also good, the wheels is also good, because as you can see here, it's used 90% of the total capacity, so it's economical. So this is how you design the connection for beam and that connect to the column. Next, you can go to Checkman tab here to see the detail of the design. This is for plates, bolts, and wheels. You can also check the stress and strain, and this you can turn on the mesh here, and this is the equivalent stress. So this is how the stress work in the connection here. You can see which point has the most stress in this view here. Next, you can also click on the deform option here to see how the member is deformed, or the connection is deformed after the load combination. So this is how the end plate here is deformed. Now after you check all this, you can run for the backlink analysis here, because it's not yet we did not do the backlink analysis yet. So you click on the calculate here and click the stress or strain backlink. So the backlink analysis now starts. So now the backlink analysis is done. You can check the backlink information here. There are 6 modes, and the critical one, it has the backlink factor 5.9, so it's okay, it's bigger than 1. So the connection here is done, and you can generate the report by clicking the report tab here. So they can use you can use the report for for the project that you're working on. Now if you're not satisfied with the connection here, if you think that the production cost is a lot, it's too much, you can adjust more, like the bolt here. I think I only need two row of the bolt here, so I'm going to change this. Something like this, and I will change this one also. I think it's okay now. Next, I'm going to delete this and select on this and copy again. So now you can run the analysis again. The production cost is less than before. You can also change the thickness of the plate here. Now you can run the analysis again. So the idea StatiCa is really easy to use, and it can have our work faster. So now the connection is still okay. So you can use this type of connection. If you want to save, you can click on the save button here, and you can name the connection you design here, and you can also create a template for a future design. So that's it. That's how you design the connection for beam to column. I hope you guys get the idea, and I'll see you guys in the next video. Thank you for watching.